All right, this is a quick video talking about the rotation of angles. So if you look at homework 9-1, we're going to look on the second page and we're going to start talking about rotating angles and labeling our quadrants. So we mentioned in class that the quadrants are labeled starting on the top right hand corner. This is called quadrant 1, and then it goes counterclockwise making a C shape. So in top left is going to be quadrant 2, and then bottom quadrant 3, and then bottom right is quadrant 4. So it goes counterclockwise, starting at the top right and going counterclockwise around the circle. So similarly, when we are rotating angles, our angles are going to rotate the same way, counterclockwise, starting from here and going around to the left, basically. So let's say I wanted to rotate an angle. I would start on the positive side of the x-axis right here. And what I would do is I would rotate my angle from that point, which is called the initial value of the angle. I would rotate it toward the left or counterclockwise, okay? So picture my angle here, starting on that positive side of the x-axis and going around, around, around. Okay, so this starting side is called the initial side of the angle. And then the ending side is called the terminal side of the angle. So initial or starting side, and then wherever we wind up is called the terminal side, okay? So let's say I wanted to rotate my angle like this into quadrant 1, and let's say that angle of rotation was 30 degrees, which is an acute angle. That starting angle here is in quadrant is along the positive side of the x-axis, and this is called standard position of an angle. So if an angle starts on the positive side of the x-axis and it rotates counterclockwise or to the left, it is considered a positive angle in standard position. Okay, so this angle ends in quadrant 1. This is called the terminal side. So starting is initial, ending, terminal. Okay. Now, we can label all the axes depending on where we start and where we end. So quadrant 1, if you start on the positive side of the x-axis here, and if I haven't rotated at all, that is considered 0 degrees. So I'm going to label this angle 0 degrees. Again, this is the initial side. Okay, now let's say I started at the same initial side and I rotated now from here to here. Oh, we got to move it over. There we go. So from here to here. Now where it ended is my terminal side. So how many degrees have I rotated? We rotated 90 degrees. So the top of the y-axis is going to be 90 degrees. Now, let's say I go back to that same angle and I start at 0 and I rotate over to here. How many degrees have I rotated? I've rotated 180 degrees. So this is going to be 180. What if I were to start at that same part from here and go all the way around to here? I'm hoping you're saying 270 degrees because these are multiples of 90 degrees. And if I were to make one complete circle from here all the way around back to the beginning, I've rotated 360 degrees. So 360 lies in the same spot as 0 degrees. So basically when we rotate positive angles, the positive angles are going to go from the positive side of the x-axis and go around to the left. Now, let's say I was going the opposite direction, okay? Let's say I was rotating from the same spot and now down. Now that's going to be a negative angle of rotation. So this is going to be negative 90, negative 180, negative 270, and negative 360. That would be going to the right, aka clockwise. So let me write that down as well. Clockwise or to the right is going to be negative angles. Okay, So that's 0. This is going to correspond to negative 90, which is really positive 270. This is negative 180, which is still positive 180 as well. This was negative 270, positive 90, and this was negative 360. So now we can fill in the box down below now that we laid the groundwork. An angle in standard position has an initial or starting side on the positive side of the x-axis. They rotate in a counterclockwise direction, which we said is to the left. Negative angles rotate the other way, which is called clockwise, and that is to the right. The angles that lie on the quadrants, on the axes, on the x or y axis, are called quadrantal angles. And those are the ones that are multiples of 90. 0, 90, 180, 270, and 360. Those are the angles that divide up the quadrants. So let's do some examples. Sketch each angle in standard position. So the first one, we're going to start on the positive side of the x-axis. I don't know where my axes went. And we're going to rotate 240 degrees. So remember, if you put in your quadrantal angles, it's helpful. So we're going to put in 0, 90, 180, 270, and 360. So hopefully you're realizing that 240 will land here, and this is called quadrant 3. Quadrant 3 because 240 is a number between 180 and 270. So to rotate it, I'm going to start on the positive side of the x-axis. I'm going to rotate it around, and I'm going to land here. That is your 240 degree angle. It's more than 180 degrees there. Now, negative 45. I'm hoping that you know that that first one was going counterclockwise because it was a positive 240. So this one is going clockwise because it's a negative angle. So if we put in our angles, 0, this is going to be negative 90. So hopefully you know that negative 45 is going to land in this quadrant down here, which is called quadrant 4. It's going to start here on the positive side of the x-axis, and it's going to go down to negative 45. It's really 45 degrees, but it's going negative, which just means the direction, okay? It's just a directed distance here. So the last thing we're going to talk about is called coterminal angles. You see the word co, and I'm hoping you're already thinking sharing. Terminal means end. So let's see what I mean by this. If I were to sketch 30 degrees in standard position, I would start here at 0, and I would just end a little bit in quadrant 1, like right about here. That would be the terminal side. Negative 330 is going to go the opposite direction. So remember, this is 0, this is negative 90, negative 180, negative 270, negative 360. So negative 330 is going to start here, but it's going to go down to the right, aka clockwise, and it's going to land, boom, also in quadrant 1. So notice that 30 is in quadrant 1 and negative 330 is also lying or terminating in quadrant 1. Now 390 happens to be more than 360. So we will go start here, go all the way around. That would be your 360, but there's going to be an extra little bit. It's going to land right about here. That's going to be your full 390 rotation. Hopefully what you notice is they all land in the same spot or terminate in the same spot. And that's why they are called coterminal angles, because they all land or terminate on the same spot, or ray, terminal ray, we call it. It's where it ends, okay? Now, how are they related in terms of their number measure? Well, it turns out that these angles, they are called coterminal, by the way. So co means sharing, and terminal means an ending side. Are angles in standard position that have the same shared terminal side. Co-terminal angles are angles in standard position that have a shared terminal side. So think about if I'm a co-president, sharing the presidency. Co-terminal, we're sharing our ending side, okay? Now, how are they related? 30, negative 330, and positive 390. I'm hoping you're noticing something. They actually are all different by 360 degrees. So to get a coterminal angle, all you have to do is add or subtract 360 degrees from the angle and you will get another one. Okay, so let's do it. 30 plus 360. Oh, you get 390. That's that one there. Let's do the other way. 30 minus 360. You get negative 330. That's that one there. So actually, it turns out we can add and subtract 360 infinite times from an angle, and thus there's actually infinite coterminal angles to a single angle. All right, so let's do one more and then we'll be done. It says find two angles, one positive and negative, that are coterminal to 100. So let's do 100 plus 360 and we'll do 100 minus 360. 100 plus 360 is going to be 460 and 100 minus 360 is going to be negative 260. So think about where it lands. 100 lies in quadrant 2 because it's a number between 90 and 180. So here's 100. If we did 460, we would go all the way around and land in the same spot in quadrant 2. And if we went negative 260, I probably subtracted that wrong. Let me double check. We are going to get landing in the same spot. So if you're not sure on your math, just take your calculator and do the angle first and then subtract the 360 from it, okay? Just to be sure. Because otherwise what happens is sometimes people reverse it and they do 360 minus 100. 360 minus 100 is 260 and that's not going to lie in quadrant 2. That's going to lie in quadrant 3 down here, which is not correct.